This video will explain how TRACC can be used to analyse access to electric vehicle charging points. This can help to identify cold spots, find out how much of a population can access an electric vehicle charging point, and propose new locations. For this example, I'll be using Bedford. In this project, I have a road network which uses Ordnance Survey multimodal routing network. This includes information such as turning restrictions and the speed throughout the day. This will help when looking at travel times by car, as it will take into account the impact of congestion. For my origins, I'll be using postcode data. This will allow me to see which electric vehicle charging points are accessible to each postcode. To add my destinations, I'll go to the Destination tab and click Add. I'll be adding these as a shapefile. I'll set the name, the description using the number of EV charging points, and set my Hansen weight to the maximum power. I'll then go to the Calculation tab and set up an origin-destination calculation using car as the mode. This will be in the outbound direction using the fastest path with a time catchment of 20 minutes. For the car speed, I'll be using 7 to 9 AM on a weekday. Click Finish to start your calculation. Once your calculation has completed, it can be seen in the Results tab. Double-click on your result to view this as a contour or a thematic. As my postcodes are irregularly spaced, I'll be using thematic. You can choose the number of ranges and the values for these ranges. Here I can see the centre of Bedford has lower journey times to the closest EV charging point, whereas those towards the outskirts either cannot access an EV charging point within 20 minutes or will take between 15 and 20 minutes. I can also view the results for a specific set of destinations. Click Create and then thematic or contour per destination. Here I want to look at only the destinations which have 2 EV charging points. I can select all of these and then click Select. This is showing access to only those EV chargers which have 2 EV charging points at that location. This can help when ensuring that there is likely to be a charging point available. You can also export your results to a CSV by clicking Export to CSV and then Result. If you would like all of the results, leave this to the default value. If you would like only the closest destination for each origin, change this to 1. Once you're happy, click Export. This CSV will contain the information about the setup of the calculation, as well as the results for each origin and destination. Here we can see that this first origin is able to access all 32 other destinations within 20 minutes. However, other postcodes, such as this one, can only access 1 or 2 destinations. Origin-destination pairs, which are not accessible within the time stated, will show as a result of 10 million. Accessible results will show the travel time and travel distance. If you'd like to carry out demographic analysis, go to the Census tab and add or activate your census data. Go back to the Results tab and click Demographic Data Report. Here you can choose the census data you would like to query, the calculation method, where entire area will have a look at access to any of the destinations, and per destination will show you results for each individual destination, and the calculation output, where sum would be the number of residents and percentage the percentage of residents. You can also set the time or distance breakdown. Here I'll be using every 5 minutes up to 20 minutes. Select the location of your output file and then click OK. Here I have the census results, both as a sum and as a percentage, for access to any EV charging point within Bedford within 5, 10, 15 and 20 minutes. This shows me that 87% of residents and households in Bedford are able to access an EV charging point of at least 50 kilowatts within 20 minutes. As I added Hansen weightings to my destinations on import, I can now create a Hansen report. This will provide a score for each origin point based on both its travel time to the EV chargers and also the weighting of each of those destinations. Locations with a higher score show better accessibility to highly weighted destinations. Here I can see that areas in the centre of Bedford have better accessibility based on both travel time and access to highly powered charging stations than those on the outskirts. If you'd like more information about this workflow, please get in touch.